So we were just able to derive a formula to come up with the length of a smooth curve over some sort of closed interval, and it is deceptively simple. I mean, we just take the square root of 1 plus our derivative squared. The ugly truth is that this process usually results in an integral that is nearly, if not impossible, to solve by hand. This is what that means. All of the problems that we're going to see in both this lesson and your practice problems are either one of two things. One of them, it's just a calculator active question. You just throw it straight into the calculator. Or number two, it has been manufactured on purpose to be something that you can do by hand. And in other words, it's just highly contrived. Anyway, yeah, so here, let me demonstrate this. Let's take something really, really simple. And something that would be simple, 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 it'd be, something like this. Y is equal to x squared. That seems pretty simple. If I were to draw its little graph here, I just have a parabola. What color should this be? How about purple? Okay. And then I want to find the length from, let's say from 0 to 1 right here. Let's say that's 1. All right, and I'll call that A to B right there. All right, on this closed interval from 0 to 1. So my length from A to B should be equal to, how about A to B? Come on, there we go. Should be equal to the definite integral from 0 to 1, square root of 1 plus our derivative squared. So we're going to take the derivative here. We got 2x. 2x, we got to square that thing, dx. Looks pretty easy, right? Okay, so let's just clean it up a little bit. Square root of 1 plus 4x squared. Okay, so here's where the problem arises, that what we have inside here, we got a composite function, right? We got a function that I just erased, a function inside of a function, which would lead us to, I don't know, maybe doing something like a u substitution. I get u is equal to 1 plus 4x squared, and then du is equal to an 8x dx. And then here is something we can't resolve. We can fix the 8 and the dx, of course, and put an 8 in here, 1/8 out here, but the x over here is not something I can fix. So you might be thinking, well, what about those little techniques where we go back to this u function and solve it for x? Okay, that's fine. If I'm going to do that, I'd have to subtract over the 1, divide by 4, u minus 1 over 4, and then take the square root of that. And that's your problem, is having this little square root plus this little square root. I said plus, but it's actually going to be multiplication. And it's going to be this kind of loop thing that, oh, I can't fix that one either. I'd need to do another u substitution, which no. So this is what I'm saying. All of these problems, as you're about to see, are going to be either highly contrived or just simply calculator active. So let's take a look at our first highly contrived example. Find the arc length of the graph of, see, well, like what? What is this function? Y is equal to x cubed over 6 plus 1 over 2x. Yes, it's just your common everyday function over the closed interval from 1/2 to 2. So here's a sneak peek of what that graph looks like. Yeah, and we want the length of this curve. Okay, let's try it then. So hopefully this one's doable. It is. All right. So we know that we're going to have to find the derivative of this thing in order to cram it into our arc length formula. So let's get this into a state where we can easily take its derivative by just rewriting this as 1/2 x to the negative 1. All right, so now take its derivative. Y prime is equal to, drop that 3 down. We got a 3x squared over 6 minus 1/2 x to the negative 2. And then let's just clean it up as x squared over, that'd be 2, that's 1/2, minus 1 over 2x squared. Okay, now we're ready to find the arc length, which we're just going to call little s. Definite integral from, oh, I put a 0 there, but I think it was like a half, right? Yeah, from 1/2 to 2. Square root of, this is like the little distance formula in here, so it's 1 plus our derivative squared. So we have this x squared over 2 minus 1 over 2x squared dx. Now, Doesn't this seem way more complicated than the one that I just generated right here? It does, but it's actually doable. Let's see how it's doable. We will square this thing out as the square of a binomial and add this 1, and then something magical is going to happen. Okay, so we got 1 plus. In the parentheses here, I don't actually need the parentheses anymore. I'm going to have x squared squared, so that's actually x to the 4th, over 4 minus, now I need to take the product of these two things, x squared over 2 times a negative 1 over 2x squared, and then I need to double the whole thing, right? Right. All right, so you can see canceling stuff out. This and this cancels out, and then I have a, let's see, 2 on the outside times, that's a 1/2 times a negative 1/2 is a negative 1/4, which makes a negative 1/2 right in here. Curious. And then our last term squared is going to be a positive 1 over 4x to the 4th. All right, and I can go ahead and combine some like terms. This 1/2 and the negative 1/2 is going to make it a positive 1/2. Let's see, x to the 4th over 4 plus 1/2 plus 1 over 4x to the 4th. Why do you keep writing 2 when you mean 4? Yeah, all right, so then you're going, yeah, what am I supposed to do with it now? Well, the hint comes from the fact that this is the expression that we got after we squared this binomial. And I have a little negative sign right there in the middle with this 1/2. This is identical to that expression, except for we have a positive 1/2 instead of a negative 1/2, which means that this is factorable. As a matter of fact, it factors like this. Square root of x squared over 2 plus 1 over 2x squared. Squared. And conveniently, this square root and this square are going to cancel each other out. Actually, it should make the absolute value, but since all of these things are positive, we're squaring that number, adding things up. We don't have to worry about the absolute value, and then it becomes definite integral for 1/2 to 2 of just x squared over 2 plus 1 over 2x squared dx. There. All right. This problem is so incredibly long, I need an extra page. Okay, so we're ready now to take the antiderivative term by term and think of this guy, of course, as a 1/2 x to the negative 2 power. All right, now you're going to see something also very, very strange that happens with these highly contrived problems. All right, so add 1 to your exponent. I've got x to the 3rd. I'll have to divide by that. There's already 2 down there, which means a 6. And then I would have, let's see, 1/2, negative 1/2, x to the negative 1, divide by negative 1. Oh, I apparently already did that because there was a plus sign here and I just made it negative. Okay, yeah. And then from 1/2 to 2, maybe make that something like this. And so here's the curious part of this. Do you recognize this function? And you're going, no, I don't recognize that function. Why would I ever recognize that function? Well, look at what we started with. Look at what we ended up with. There's only one little difference. It has this little negative sign where it used to be a plus sign. This is crazy. It's just craziness. All right, let's go ahead and throw our stuff in here. 2 cubed over 6 minus 1 over 2 times 2 minus, boop, I have 1/2, which we're going to cubed over 6 minus 1 over 2 times 1/2. Is that a safe stop? Technically it is, but I'm going to get the practice of my arithmetic. 8 over 6 minus 1/4 minus an 1/8, looked like 18 to me, over 6 minus 1. Here we go. Get rid of our parentheses. Let's reduce this fraction to a, let's see, that was 8/3, that would be 4, or 8/6, that would be 4/3. Okay, all right, so 4/3 minus 1 fourth minus this 8 is just going to come down on the bottom. So like multiplying this 8 over 8 there, that makes 1 over 48 minus 1. And, oh, no, actually plus 1, yes. I'm going to, just because this part is pretty easy, I'm just going to combine the 1/4 of the 1, make that 3/4. Weird, right? Okay, if you say so. Plus a 3/4 minus 1 over 48. All right, and now I'm going to combine these two. I would have a common denominator of 12. That first fraction needs a 4, so that'd be 16. The next one needs a 3, so that would be a 9. See this magic happening. That's a 25 over 12 minus 1 over 48. Now a common denominator of 48. This one needs a 4 over 4. That's 100 over 12. Oh, no, over 48. Minus 1 over 48, which makes 99 over 48. And I think that that divides by 3. So divide by 3, we get 33. Divide by 3, we get 16. There you go. There's ArcLink. So easy. So nice and simple.